All right, today we're going to take a look at Chapter 8, Section 5, Applications of Matrices and Determinants, and take a look at what we can do with these. We're only going to look at the first half of the lesson today, but have your in-class worksheets handy. We're going to go over the first page of that, and we'll get started on the web assign, but we're only going to get through half of the lesson today. What are we going to take a look at? How to use a determinant to find the area of a triangle. Kind of an interesting concept that we can use matrices to actually find areas of triangles. Use a determinant to determine if points are collinear. And finally, use a determinant to encode and decode messages. We're going to do that next class. So, determinant application, area of a triangle. The area of a triangle with these three sets of three vertices, x1, y1, x2, y2, x3, y3, so these are three different points, is determined by plus or minus. Now, the reason we have the plus or minus is that area is always going to be positive. So if this determinant turns out to be negative, we have to switch the sign. If it turns out to be positive, we leave it positive. But the area of the triangle is going to be 1/2 the determinant of the matrix formed by x1, y1, and then a 1 in column 3, and x2, y2, 1, x3, y3, 1. So let's take a look at an example and see how we can calculate that. So here is 3 points, 2, 4, -1, 5, 4, -3. If I want to find the area of the triangle with these given coordinates, it doesn't matter which order I put the matrix in. So I could do it just like this: 2, 4, 1, -1, 5, 1, or 4, -3, 1. Or I could mix up the rows anyway, doesn't matter. So let's take these 3 points, and we'll use that first one, 2, 4, 1, -1, 5, 1, 4, -3, 1, and we're going to take half of the determinant, plus or minus. So I'm going to go use column 3, the one that's got all ones. That's going to be easiest. Now remember, when I'm finding the determinant of a 3 by 3 matrix, if I'm going to use column 3, it's going to be plus, minus, plus from our cofactors that we learned last lesson. So plus, minus, plus. So plus or minus 1/2. Now I'm going to take 1 times the determinant of this little matrix that's left over, -1, 5, 4, -3, minus the second one, which is going to be 2, 4, 4, -3, and then plus 1 of this one, 2, 4, -1, 5. So calculate the determinants. Again, leave this plus or minus 1/2 out in front. I'm going to have 3 minus 20 minus -6 minus 16 plus 10 plus 4. So what does that give us? That gives us plus or minus, if I do all the math here, 1/2 of 19. Well, we'll just take the positive 19 here, which is going to be 19, and then we have to divide it by 2, 19 halves. So the area of the triangle with these 3 vertices is 19 halves. All right, let's find, this is a little bit trickier here, the value of some unknown y such that the triangle with the given vertices has an area of 4 square units. So my 4 points are -4, 2, so -4, 2, 1, -3, 5, so -3, 5, 1, and now -1, oh, here I've got an unknown, I've got y, so -1, y, 1. And again, I'm going to use column 3 to calculate the determinant. So it's going to be plus or minus 1/2, -3, 5, -1, y, minus -4, y. I'm sorry, -4, 2, -1, y. And then plus, for the last one, -4, 2, -3, 5. Calculate the determinant of this. And remember, we're going to take plus or minus 1/2 of it. -3y minus a -5 is a plus 5, minus -4y plus 2, plus -20 minus a -6, or plus 6. If I do the math, I have 4 is equal to plus or minus 1/2 y minus 11. Multiply both sides by 2, and that gives me 8 equals plus or minus y minus 11, which tells me y is equal to 19, or y is equal to 3. So the way you can visualize that is that you're going to have, if you have two known points, you're going to have two unknown points where the triangle can be formed that has an area of 4 square units. So let's take a look at worksheets 1 through 4, so you can get that out, and let me go find mine here. Taking me a second to find it here. All right, under chapter 8 here, we're going to go down to the in-class worksheet and take a look at 1, 2, 3, and 4 here. So for number 1, I did it the long way here. Oops. So I've got these 3 points, and I want to find the area of the triangle with these vertices. So it's -2, 4, 1, 2, 3, 1, -1, 5, 1. So area is going to be plus or minus 1/2. Using column 3 again, I'm going to use 2, 3, -1, 5. So that's going to be 10 plus 3, minus for the second one, -2, 4, -1, 5, is going to be -10 plus 4, plus the last one is going to be -2, 4, 2, 3, -6 minus 8. So if I calculate this here, plus or minus 1/2, 13 plus 6 minus 14 is equal to 5. That's positive, so we don't need to change signs. So 5 halves and units squared. If I wanted to do it the easy way, I could plug this into my calculator, find the determinant, take half of it. So the determinant of this is 25. Half of that would be 25 halves. If I did this one, turns out to be 56. Take half of 56 equals 28 units squared. All right, let's take a look at number 4 here. Find y so that the triangle would have an area of 4 square miles. So here's my 4 points: -4, 2, 1, -3, 5, -3, 5, 1, and then -2, y, 1. And that's going to be equal to 4 square miles. So the area of this triangle is going to be plus or minus the determinant of this. Well, I don't know what y is, so I have to solve for it. So it's plus or minus 1/2. Now I'm going to take 1 times the determinant of this, -3 times y, minus 5 times -2. So -3, 5, -2, y. So -3y plus 10, minus, because I'm going plus, minus, plus, minus, here I've got -4, 2, -2y, negative 4y plus 4, plus the last one, negative 4, 2, negative 3, 5, negative 4, 2, negative 3, 5, is negative 20 minus a negative 6, so negative 20 plus 6. If I do the math here, negative 3y plus 4y gives me a 1y. 10 plus 4 minus 20 plus 6, if I add that all up, is a negative 8. So 8 is equal to, so if I multiply both sides by 2, that gives me an 8 on this side. And I've got a y plus or minus y minus 8. So that tells me that y is either equal to 16, because 16 minus 8 is 8, or 0. 0 minus 8 is negative 8. Switch the signs and it becomes 8. So for number 4, we've got 16 or 0. All right. So the last thing we're going to look at here is determining if lines are collinear, if they lie on the same line. I'm going to set up my matrix just like I did for a triangle. Well, if you think about it, if a triangle has an area of 0, then it has no height to it. So if my determinant here is equal to 0, then I know that these 3 points are on the same line. So we'll take a look at an example. All right, we'll use the determinant to determine if these 3 points, negative 3, 5, negative 5, 6, 1, 10, 2, are collinear. All right, so again, negative 3, negative 5, 1, 6, 1, 1, 10, 2, 1. I'm going to use column 3. So 1 times the determinant of this matrix that's left over minus 1 times this matrix, negative 3, negative 5, 10, 2, plus 1 times this matrix, negative 3, negative 5, 6, 1. So I'm going to calculate what this is equal to. This is going to be 12 minus 10 minus negative 6 minus a negative 50 plus negative 3 minus a negative 30. If I do these all up, so 2 minus 45 plus 27, I don't know what that equals to, but it's not 0. So it is not collinear. I'll give you a second or two to get those notes down. Again, if you need to come back and review the notes, you can do that on the YouTube video that's on the class page and should be able to pick up whatever you missed. All right, we will continue on. So if I know that 3 lines are collinear, and I can use that fact to find another point on that line. So it says find the equation for the line passing through the given points. Here I've got 2, 4, 1, negative 3, 4, 1. I want to find the missing x and y. Okay, I'm not going to find the values for them. I'm going to find an equation that's going to satisfy this situation here. Now, here they expanded on the first row. We could have used the third column. It would turn out the same. Either way would work. But if we do it with the first row, it's going to be x times this matrix that's left over, 4, 1, 3, 1, minus y, because remember it's plus, minus, plus, so minus y times this matrix, 2, determinant of this matrix, 2, 1, negative 1, 1, 2, 1, negative 1, 1, plus my third row, a third column in this row, 1 times this matrix, 2, 4, negative 1, 3. So if we calculate that out, this is x times 4 minus 3 minus y times 2 plus 1 plus 6 plus 4. Calculate this out. This is going to be a 1x minus 3y plus 10 equals 0. So let's take a look at 5 through 8 here. So use the determinant to determine whether these points are collinear or not. I could do it the long way, but I cheated and just used my calculator and figured out it was 0, so therefore it is collinear. Did this one equals -21, therefore it's not collinear. So that was pretty easy. You can try those on your calculator. Number 7, find the points such that these points are collinear. So I want to find that missing y. So I've got 2, 5, 2, -5, 1, 4y, 1, 5, -2, 1. So I want to find it's collinear, so they're going to have a determinant of 0. So I'm going to use column 3, 1 times this minus 1, because it's plus minus plus, plus 1 times this. So I've got 4y, 5, -2, so it's -8 minus 5y minus -4 minus a -25 plus 25 plus 2y minus a -20, so plus 20. If I combine like terms, so -5y plus 2y gives me a -3y, -8 plus 4 minus 25 plus 20 would give me a -9. It tells me y is equal to -3. Let me scroll down here a little bit. You can still copy those notes if you need them. Finally, let's take a look at use the determinant to find an equation of the line passing through the points -4, 3, 2, 1, and I want to have whatever x and y satisfies that equation will give me a determinant of 0. So xy 1, -4, 3, 1, 2, 1, 1. Now in the example before we used row 1. I'm going to use column 3 because I can. So column 3, I've got 0 times -4, 3, 2, 1. So -4 times 1, -4 minus 6 minus, now because it's plus minus plus, minus xy 2, 1. So x minus 2y plus, I'm going to have xy -4, 3, x times 3, 3x minus a -4y plus 4y. Combine like terms. I've got 3x minus x is 2x. Got 4y plus a -2y is 6y. And then here I've got -4 minus 10 is minus 10. That can reduce to divide through by 2. X plus 3y minus 5 is equal to 0. So let's take a look at that. And sure enough, collinear, not collinear. Y was equal to -3. X was equal to plus x plus 3y minus 5. So let me go back to that slide real quick so you can finish up those notes. All right, that is as far as we are going to get today. Next class, we'll finish up this lesson. But you should be able to get started on the WebAssign. And again, I'm going to ask that you turn in the in-class worksheet into the Google Docs, not next class, but the following class. So go ahead and finish up the whole thing next class. So nothing to turn in next class, but please do get started on your WebAssign. So that is all we're going to do for today. And I'm in the room.